Assalamu alaikum, ladies and gentlemen. Welcome back to another live stream. Alright, let me copy the link real quick. Okay. So this is part 3 of this project, pretty much. Okay. Should probably make a tag for pings, honestly. Anyways, alright, so let's bring out the chat here and let's grab VS Code. So there you go. Alright, let's get going, I guess. I have no clue what we're gonna do today. Probably we're gonna work on maybe if conditions and stuff like that. Last stream we have successfully parsed this into an AST. Of course, currently we're only focusing on the parser itself. So this script right here produces this AST pretty much. So a let statement, let numbers, right, with the dot operator, and the first is some number 0, some number 10, right, and the call after that, like in the dot operator, in the second operand of the dot operator, you have a for call, you know, and inside of it there is a closure, there you go, with one argument which is x, and then we have multiply add identifier x with number 1, number 2, etc. And finally, after this semicolon, we have no other statements, so we just get end. And that's pretty much what we got so far. This is what we have. We have a number identifier, let statement, multiplication, division, addition, subtraction, call, tuple, closure, range, and the dot operator, and finally the end token, or to end the expression. Okay, cool. So what do you think, guys, should we work on today? What do you guys think? Interesting. Right now we could also, instead of that, we could actually go, let's say, return numbers, you know. So instead of end, you would return identifier numbers. Anyways, so that's pretty cool stuff. So I guess let's get going and see. I think first of all, maybe I'll try to find if there is anything to, cause like in the previous video, I just kept on copy pasting a lot of things. So maybe we can make something more reusable, especially in terms of tuples, ranges, etc. Okay, so clone or not, separated by just that, exactly to the limited by, padded, separated by just, okay, so I mean, anyways, I guess let's just, yeah, what I wanted, yeah, last video, what was the question really, is how we can, because right now, like, the closure body only accepts an expression, but like we cannot do, let's say, multiple expressions, I think. Yeah, probably cannot do that unless if you use a tuple though, but yeah. And we can't of course use let because it's a statement here. So I'd love if we can find some solution for this. Good question. How are we gonna do this? Okay, so basically what I want is to be able, so like our let statement can contain an expression after the equals, right? But we also want the expression to potentially contains let. So that's very interesting. What if we actually put it this, you know? What if we put it all of, well, not necessarily all of it, I guess. But at least the expression, you know. What if we put it inside of this recursive block? Let's make sure we haven't broke anything, first of all, by doing this change. Okay, I mean, I guess seems fine. Okay, so, alright, great. So how are we gonna do this now? So we have range, tuple, call, closure, value. So here's closure. So what we're doing is we're getting well, that's basically for the arguments, and then we're getting expression.clone. Okay, cool. So how can we do this? Expression. What if we made let also value, if that makes any sense? Huh. I mean, we can try. It doesn't hurt if we try it, I guess. So since right now it's inside of this, we can actually use this guy. But we probably want to clone it, right? Or isn't it? Yeah, probably. So where I should do that exactly? I think right here. Yeah. And maybe that's all we need? Is it? That would be nice if it is. Let me make sure that, okay, looking all good to me. Anyways, so yeah, I mean, everything seems to be still working fine. But right now, what happens if we add a let statement here? I don't know honestly what to expect here. I have no clue what to expect right now. Okay, found. So I actually do not want it to put the range here. That sucks. We're already using the range for the error reporting. So how can I actually remove that? We're using another library for errors. We're using Ariadne, and hey Theo Paris, welcome to the live stream. And Theo have become today our new admin. There you go. Let's go. All right, so let's see. Ariadne, get version 0.4.0. Okay, so let's get going. So with message here, we're actually saying toString, but I don't want the span. How can I remove that? That's the real question, I think. Good question. So how to do that? Can't I just get the reason somehow? What is this found thing? There's merge expected. Well, hold on a second. Let me go to the actual documentation of this maybe. So what is the type of error? It's simple. Okay. Okay, so we have a span and we have found. Get the token if any that was found at the error location. Oh yeah, let's go. All right, that's cool. So we can basically say, I guess, with message error.found, and that would actually give us an option. Let's just unwrap it for now. Okay, let's see what's gonna happen right now. I think it would only print this right now. Yeah, there you go. But we don't actually need that in the first place. So yeah, that's true. Because we're just using like a simple error right now. I'm not sure if we can actually use better error handling. I mean, we can, but I don't know if I can actually do it myself. It's a skill issue, I guess, right now. So we just gotta basically make use of, instead of simple, we gotta make use of rich error handling. But I'm not entirely sure how that exactly works. Though we can maybe check out some examples. I guess we'll see about that later on. Either way, right now let's just make a simple error. I guess let's say character unexpected, or what should I call this? I don't know, man. Unexpected token, I guess. No clue. Anyways. So, but hopefully we can do some better error handling later on. Either way, so we have a problem here. For x, let y equal to x. So why that is the case? Can that be fixed just by changing the priority by any chance? Cargo R. Okay. So is this what we actually want? Let's see. So. Okay, cool. Range, great. For closure argument x, let y. Okay, hold on a second. Let y equal to identifier x and end. Man, let's go. That's what I'm talking about. Oh. What's up? Unexpected token. But why that worked and now it doesn't? Are you kidding? Maybe the span is wrong or something. Is it? Maybe not. So why this happens? Interesting. What? Now it doesn't work? How? How in the world? It just worked. No? Or maybe I didn't save? What the heck? Bro, you run it twice and it doesn't work anymore. Amazing. Perfect. What? Oh, what if I added a space here? What? Bro, I'm super confused now. Okay, what if we say this? Yeah, I guess that works. But why, when we do multiple lets, it doesn't work? That's the real question here now. It should work. Okay, so this one, if we put it here, it actually works. Look at that. But what about here then? Weird. Maybe, yeah, I probably have something that I'm missing here. Maybe the semicolon is playing with me here or something. I don't know. That's weird. So maybe we do need that block syntax that Rust have after all. Well, maybe. Maybe. Interesting. Okay. So how are we gonna do this? Okay, well, let's try to make that block syntax, I guess. Hello, Robert. Welcome to the live stream. How is it going? I guess it's your first time here. Welcome. Okay. Let's see. Alright, let's try to make a block. I've never done this before, so no clue what to expect here. Yeah. Okay. So where to even start with this? let block is equal to, so what we're gonna parse. So it's gonna be a bit similar to a tuple, I guess. So we can inspire from that, I guess. Let's grab our block, right? Let's put it near the tuple so we can do some copy pasting job. Okay, so we need expression. And of course we have to clone it and separate. Well, I mean, let's start from this pretty much, and then change it to what we want. Okay, so of course a block would be delimited by these, right? Cool. Okay, do we want to allow, and it's gonna be separated by semicolons. And do we want to allow trailing? Does it even make any sense? Actually, yeah, we do, right? Because the last statement could have a semicolon or can not have a, depends pretty much. But like the fact that it have a semicolon or it doesn't actually matters, because if it does, at least in Rust, you don't return that value from that block. Yeah, I think, am I right or am I confusing this with another language? But I think even in Rust, like you can actually do computation here and it would actually return from the block, right? Yeah, it is. Look at that. There you go. So you could do some interesting computation. I don't know. And then you could return it, right? So I32. But if you do this, you get a unit, which is basically void in other languages, in C family languages. But yeah, that's interesting. So it is in some sense an expression after all. That's cool. Okay, so expression clone separated by just that, allow trailing, collect vec. And maybe that would mean we can generalize the other statements too with this, like the for loop, etc. We still haven't implemented those yet, but we can maybe use it for let, for example, and stuff like that. Anyways, so expression separated by just that, allow trailing, collect to a vector, delimited by just. Okay, looks good to me. So we're gonna need a block here in our AST. So block vec expression, there you go, src, let's go. I think that's basically it, just a vector of expressions, I think. It's like args. Okay, anyways, so now we have that out of the way and we're just gonna map this. We're gonna map this into a expression block. There you go. And now let's actually try to shoehorn this into our value again and see if it works. Block. So let's remove let for now. I don't want that to mess with my stuff right now. And let's just put, instead of that, a block. And let's see if the magic happens. No clue if this would work or not. Cargo R. I'm not sure honestly how to detect like conflicting syntax or grammar rules using functional parsers. There is some debugging information, like there is some information that would help with debugging here in here, I think, but I haven't read through that yet. Guide maybe, or MISC? Error and okay, there's debugging here to do. Okay, error and recovery to do. Okay, key concepts meet the parser's recursion. I have already gone through these. What about MISC? No. Okay, well, Okay. Anyway, so what's the problem here? Let's see. What if we have a block right now like this? Cargo R. And yeah, inside our closure, we got a block. Let's go. Let's try to fill this block with something. I don't know. Right now, it's not really a block. Or is it? Yeah, it's not really a block. Because you cannot, of course, right now do this, right? But you can probably do something like this, like a table. I guess. Parse error. Interesting. Oh, my bad. It's gotta be a semicolon here. Okay. And there you go. So block, identifier X, identifier Y. Great. But of course we cannot yet do this. Right? So let's just say this, I guess. And yeah, we cannot do this now because we have to actually include our let block. So what if I actually included this here? Would that work by any chance? Huh? No, an expected token. Interesting. So maybe instead of putting it here, let's actually put it in the... But hold on, no. Hold on a second. I'm doing this wrong. So we don't want actually expressions, right? We actually want more than that. Okay. Huh, interesting. So how can we actually reference block here? Good question. And we can do that. Let's block. So first, what we want to actually do here, we want to basically, I guess, maybe we could do it here, and then you would just maybe use the let. Huh. Expression delimited by. Let's see. Call number identifier. Okay, what if I bring my block out of there and maybe I put it text keyword let r let. So if I do something like this, right? And instead of expression, maybe we could go with let, maybe, and then final return block. Huh. Am I saying nonsense? Our let clone. But the thing is with this is that currently we're actually handling that let stuff inside of itself in some sense, right? So let keeps track of the next let statement or whatever other statement, right? Or basically expression, right? So we don't want that anymore because we're gonna have a block to do that for us. Huh. So maybe then it would be something like this. So the whole program would be inside of a block. Okay. And then maybe we could say something like that. Okay, I guess let's try it. I mean, we can always revert using get. So let's just experiment. I honestly am not sure about this. So, okay, cool. Cool. So we do not need, so let's see, where is it? Let. Okay, so here is let. So here we actually have a let. Well, we have a then expression. So I think we're not going to need that anymore. We're only going to need the name or the identifier, right? Of the let statement and the actual expression value. And the block would do the rest. Okay. Cool. So let's see where we're actually using this. Alright, so we can remove this. Okay. Now let's see what's up. Then expression clone, then ignore. So we don't need this anymore, and we don't need this anymore. And we don't need then anymore either. Is that, yeah, there you go. Expression let, identifier box, new expression. Great. So nice. And yeah, we got let. So a block is just, you know, a bunch of lets right now, separated by just that. Okay, let's see if this actually works by any chance. Hopefully I didn't break my other stuff. Let's see. Probably should write some unit tests. An expected token. Why that's the case? Oh, maybe because of padded? Maybe we need padded? Isn't that the case? I think so. Separated by just. So let's try to say padded, just in case. Maybe that's the reason why it's broken. Cargo R. Okay, what if I put a semicolon there and it doesn't work with that? Why? I mean, we have allow trailing here, so it should technically allow trailing semicolon, because this one is a trailing semicolon, right? Well, let me just inline this right now, just so I can see if there's some weird thing going on here. I don't know. Oh, it works now? Okay, but if I add a space there, I see. So, okay, gotcha. So, where should we actually put this then? Allow trailing, collect, delimited by just that. So, here we got the let keyword. And that is padded, ignored, and then expression.clone. Maybe dot padded? No? Crap. Map identifier expression. Well, I guess one way to figure it out. Okay, no. Let me try to think about this. Map, then expression clone. So currently the let is only parsing this stuff right here, right? Oh, but because there is a space here, not in the actual let. My bad. But yeah, why didn't it work then? Oh. I don't think... Oh, maybe I should actually put the padded in with this? Huh. I mean, it seems to work now. Okay, let's try some bunch of spaces, I guess, right now. Okay, cool. So I think right now maybe a block works. And the whole program is just a huge block. Well, yeah, it's not huge right now, but you got the point. Let's make sure this works. Okay, so let's make sure that our other stuff is still working. I don't know. Let's see. Okay. All right, let's try that syntax that we made, right? So let's try some floats too. Why not? And let's map some closures, I guess, and then yeah, I think that should be fine. Okay, cool. It works, I guess. Yeah, that seems good to me. Nice. And yeah, this is our whole program. But yeah, I don't think I can do this. I don't know if I want to do that. Yeah, I do want to do that. Yep. But of course that wouldn't work right now. Because if you want that to work, first of all, our block should be part of value, but also our let should be that is crazy. Okay, let block. So can we actually make use of recursive here? Yeah, I think we could probably make use of recursive here. Recursive. So closure. What's up with this? Hold on. What I'm doing? Oh, I see. Okay. So let block is equal to recursive. And this is our block. And this whole thing is an expression. Okay. So cool. Now what? Well, we could just return this. I mean, yeah, we're returning it anyways. So now what we could hopefully do is just copy this whole thing inside of there, I guess. Did we break anything? Well, I cannot know with that in place. Okay, cool. We didn't break anything. Great. Okay, so let's try this out now. So we have that. Okay. So our let statement, where is it? Yeah, a block should be here, right? Yes, pretty much. We don't want a let there, I think. Yep, probably not. And then I don't need this, honestly. And then what we could do right now is, instead of just hopefully just returning block, we can also return let. Is that even possible? Oh crap. Our let clone separated by just that. Huh. Well. Yeah, my mind right now is like a higher level mathematical function. I'm not made for functional programming. Let's see. So basically what we want to do, kinda, is block or a let statement. I mean, to be honest with you, I don't want to allow that either way. Yeah, I just wanna, well, hold on, what? Yeah, honestly, hold on a second. Cargo R. Cool. Now, can I do something like this? I don't know, let Z is equal to, something like this. Oh, an expected token. Huh? Okay. So we got that let Z with a block. And then Yeah, there you go, it works. So now we can actually do something like this, which is pretty cool, pretty sick. Let w equal to number 10. But why didn't it allow me to do something like this? But what if I added the semicolon there? It doesn't accept it either. Why? Oh, let me see the block again. So this is our block. Oh, it's actually just a let statement only. Interesting. Well, I guess maybe we could easily do it with or expression. Hopefully I wouldn't blow anything up here. Do we even have access to expression here? I don't think so. Oh crap. My mind is a recursive fractal right now. Let expression. Huh. Yeah, but the problem with this, it wouldn't allow us to... Hello, Hanok. Welcome to the live stream. How is it going? Welcome, welcome. Thanks for the star, by the way, on the GitHub repo. Or maybe it's not you? Yeah, I think it was someone else. Yeah, my bad. But welcome anyways. Or let or expression. Cannot find value expression in this scope. The binding expression is available in a different scope in the same function. Yeah, makes sense. So can we actually store the expression outside of this block? Like maybe using the option? Does that even make any stupid sense? Like, I don't know. If I said option none, right? Yeah? And then I said expression is equal to that. Of course, this should be mutable. Why is Rust hard, by the way? I mean, it's hard for a good reason. Unlike C++, which is hard for no reason. Just keep at it, bro. Just keep at it. It's pretty worth it. Like, you're gonna realize why everything is in that way in Rust. How it is done step by step. It's a pretty steep learning curve, but once you get to it, it's very, very fun. Syntax error expected semicolon. I lost track of what I was even doing here. Hold on. Let mutable expression. So yeah, can I say some? So where is this now? Recursive. I think right here, maybe? Oh. Maybe here? Okay. Huh? Yeah, let's actually unwrap this now. And unwrap this now. Would that work now? Oh, I see. So clone it, please. Ah, I see. So unwrap, clone. So it's got moved there. Interesting. Interesting. So I think we have to basically get a reference first of all. Unwrap that and then clone. Yeah. So we don't move the option. We don't move that out of the option. Because without this asref, we wouldn't move. We would actually move the expression out of the option. Okay, but if we get a reference first, then we unwrap that reference and clone it, we should be all good. And there you go. So I'm not sure if this would honestly work, but what I've basically done, I need access to this expression outside of this closure, right? So and of course we cannot have an initialized memory in Rust. Well, I mean, you can use it in safe Rust, but that's out of the question right now. So what I've done, I just made an option none, right? And then I just initialized it later on with some expression, and then I just unwrap it and stuff. But yeah, let's see if this actually works by any chance. So right now the block is not actually, or is it? Hold on. What is this? This is the let, I guess? Bruh, I don't get it. I should probably make this into multiple subparsers so it should be easy to grasp with my little brain. But there you go. Let's see now. I think it actually worked. Huh. Really? Bruh. That is amazing. Let's go. Okay. Very cool. Now that we actually got a block. And though, hold on a second. We're not done yet, maybe. Can we actually do something like this? What? I mean, yeah, I programmed it to do that, but I'm still surprised that it worked without an error from the start. That's very interesting. So we got a closure, right? With an X argument and a block with a let statement and identifier W. Okay, that is very cool. The only problem though I have with this is the fact that we're using allow trailing, which does allow us to either omit or include the semicolon. But the problem with this is that we don't have any idea if we do need to know if the semicolon is omitted or not at the end. Right now we're just making it kind of like a convenience basically, but that's not the case. That's part of this. That should be part of the syntax. So what we're gonna do, I guess, instead of allow trailing, I think separated by just semicolon dot collect vec dot padded delimited by just dot padded delimited by just that. Can I do, well, actually before it maybe, right? Actually, hold on. Let me just comment that out, right? And let's say, so separated by, maybe I actually have to do it here. No, probably not. It should be in the end, maybe. Okay, let's try it maybe here, I guess. So basically what I want is then just a semicolon, right? Okay, but of course that semicolon should be optional. So I'm gonna say or not. Right? I mean, the compiler doesn't say right for some reason. What if I do this? Nope. Why? Ah, I see. Interesting. Okay, my bad. So I need to actually modify the block right now. Well, do I really want to do that? Yeah, I think so. Because it's basically, interesting. Ba-ba-da-ba-ba. What should I call this? Well, for now, I guess I'll just have it as a boolean. Pretty much. Okay. So basically this would tell us if there is a semicolon at the end or not. And depending on that, we're gonna either return the value outside of the block or not, I guess. Maybe. Maybe I can make this into a tuple to Avoid making a new closure. Maybe? What's up, bro? Type mismatching function. Arguments expected function signature vec. Ah, I see. So it's an option char. Interesting. Option char. Well, I don't really care, or do I? Huh. Like, how can I... Oh yeah, maybe I should map it? But no, what the heck? How can I map an option to... Well, I guess I just map it, right? Or is it? Bruh. Bruh. Option is sum. Does that make any sense? By any chance? Expected operand. So this is the option chart. There you go. Cool. And maybe we could just say a sum, right? Oh, okay. What about now? So here it said false. Right? What if I added the semicolon now here? Oh, crap. What the heck? Parse error. Parse error. Oh, crap. But why? What? I'm getting that thing again where I save and now it doesn't work anymore somehow. What the... Bruh. Okay, so right now it's false. If I add a semicolon... Okay, I see. Okay, cool. Good. So how are we gonna deal with this? I think I'm putting it in the wrong place, probably. Okay, what if I added it... here, maybe? Or... no? Maybe... I want to put it on the end, and this really confuses me. So where I had it before, I think here? Okay. Well, I don't think that would work actually, because it would be like after the block, possibly. No? Huh. Yeah, of course not. I'm confused right now. Okay. So this one is true. So yeah, we do have a semicolon there. Right? Yes. Cool. And this one doesn't have a semicolon, so yeah, that works. Let's go. So that false and this one is true. Let's go. That's pretty cool stuff. Let's go, man. Nice. Now, I wonder how can I make this block optional? Huh. Well, maybe let's not think about that for now. Anyways, so there you go, we got this. Nice. Now, maybe we can add some if conditions and, you know, control flow. So like something like, I don't know, for x in actually in Rust you don't need the parentheses though. It's optional. I'm not sure if I actually made it optional. Did I? Let me try. Okay, no, I probably didn't. Yeah. Right? What? This is wild. Why this doesn't work now? I think spaces are playing tricks with me right now. Yeah, it's probably because of spaces. Oh my god, I hate those. Okay, so if I added an extra space... What? No way. What the heck is going on here? I'm confused now. What if I did this? Okay, so we got just a block. Cool. Let x equal to from 0 to 10. Okay, I mean, it works. I don't know why that sucked. But yeah, why that didn't work then? Why? Oh, I don't have a semicolon here. Okay, gotcha. What if I added a semicolon? I see. There you go, man. There you go. Okay, cool. Cool. So yeah, that still works. But I think this doesn't work, right? So I don't think I've done it yet. Programming language, debugging language. Oh yeah, I really need to look up for some better error handling. There is some examples here. In fact, there is a nano Rust here implementation, which is interesting. And look at that, they're using a rich error, which is supposed to give you more nicer and more descriptive errors than just the one that we're using, which is simple. But I do think that comes with its own stuff to think about, I guess. Maybe. And also this one is actually, you know, separated by like a lexer, and like basically it's two parsers. There is a lexer parser and then another pass, which is the actual parser itself. Even assembly was easier for me, which I thought was oh my. Let's go. Okay, so basically I didn't make this optional just yet, and I honestly have no clue how to do that. Let's see. So this is our range parser. Separated by just that. Okay, exactly 2, collects exactly limited by just. Okay, so can I make this optional? Good question. What if I just did it dirty and said maybe or not? Or not? I don't know, that could go horribly wrong, but you gotta do what you gotta do, I guess. There you go. Thread main has overflowed its I honestly didn't expect that horrible. I just expected a normal, you know, parse error. But I actually caused an overflow of the stack somehow. Interesting, yeah, that indeed happened horribly. Oh crap. Okay. I wasn't expecting that to be that bad. Interesting. Time to go Stack Overflow to find the solution. Yeah, that is wild. This is the first time that I get this error in Rust, pretty much. Okay, so let's try something else because that apparently doesn't work. Huh. So how are we gonna do this? How to make the delimited by... I mean, we could do it dirty, I think, and then just make a second range parser which doesn't contain that. I guess let's just do it, I guess. I mean, that's the most simple solution I can think of right now. So I just gotta delete this delimited by, and there you go. Where can I find your GitHub, by the way? Yeah, it's... hold on. Where is it? There you go. This is the Git repo. If you guys wanna commit some pull request or issue, feel free to do so. If there's any pull requests or issues, we're gonna review them in next streams, pretty much. So feel free. Okay, so basically I have range 2 and range, cool. Actually, I'm gonna say range 1 and range 2. And then I'm gonna say the actual range is range 1 or range 2. Okay. Let's see if this works. I mean, that's the simplest way I ever thought about fixing this. Oh crap, what the heck? Are you kidding me? I apparently overflowed the stack again. Interesting. Cannot find value range in this scope. Yeah, of course. Let's just do this. An expected token. Yeah, true. So let's see how we're gonna do this. So apparently this also overflows the stack. I'm not sure why, but it's probably a bug in the library. Because right now there's a they're very much working a lot on it. There's a lot of breaking changes on Chomsky right now because it's still in alpha, so that's to be expected. 3 days ago, fixed foo example. Interesting. Okay. Alright. Oh my god, look at that juicy ears. That would be cool. Anyways. So I don't think we can figure this out right now. That seems like a hard stack overflow there. Okay. What if we commented this out and just use this instead, and then we don't use the parentheses at all? I don't think that would go well either, but let's just try it out. What? What the heck is going on with this? Huh. Really? Okay, now I'm confused. So apparently that solution was probably good. It's just that there is something weird going on here. So without the delimited by, it doesn't work. It causes the stack overflow for some reason. I mean, we're playing with arrays here, so maybe I'm missing something here. Okay. Okay, let me try to read through this. So we got expression or not, separated by just a dot and a dot, and okay, exactly 2 times, and collect exactly. Collect exactly 2, and then we map it. Maybe separated by is not supposed to be used by itself. I mean, they are using it here, but what's up with this? Weird. Well, anyways, let's forget about this for now. Let's just go with the original one. But hopefully we can figure it out later. So let's just get back our ranges. And there you go. Cargo R. Great. Okay, so basically what we want right now is to, I guess, say something like maybe 4i. 4i in 0.10 maybe, something like this. And this is basically a block, right? And you can do whichever you want here. Okay, how we can do this? So we're gonna basically parse the keyword for, then parse an identifier, or actually even maybe multiple identifiers possibly. Like if we have later on some hash maps, I don't know. Maybe we're gonna need that. But anyways, for now, it's fine. Just one identifier, then we're gonna parse a keyword n. Then we're gonna parse an expression. And finally, the body of the for loop would be the block after it. So yeah, I think that should be straightforward to do. Unless if I'm missing the whole point. Okay, so we don't need this anymore. And let's see what we could do here. Oh crap. Oh my. So this is recursive. It's gonna make for us some problems maybe. Because this is inside this scope. Okay, so well, I guess we could do something maybe. We could just do it here anyways. It's gonna become a spaghetti for parser, but you gotta do what you gotta do, I guess. Okay. So this is our let right now. Is equal to that, and finally we're gonna return let. Oh crap, let like this. Is that right? And expected, oh yeah, makes sense. Alright, so now what? Yeah, let's try and make the for loop now. Let r. Actually, would that really work? In fact, why we're making this recursive thing in the first place? Oh, actually this is a recursive for the block. Or what? Hold on. No, it's for the let. But why we're making this recursive? That's the real question, I think. Maybe it was because of something that we wanted to try before, but we didn't do it after all. Yeah, I think so. Probably that's the case. I mean, we're not using that thing anywhere. Like, actually, hold on a second. Let me just comment this out, because I need this right now. Oh crap, look at that, our warnings. Okay, look at that, in used variable. So we actually don't need this. This is just something that, like a previous solution that we were battling with, basically. Okay, so that's great. That's amazing. So what we could do, let's first of all take this off from here. Alright. And let's make sure we haven't effed up anything. Okay, cool. And now, yeah, I don't need this recursive anymore. Cool. Let's go. Great. So it's actually good to go. All right, cool. So thank you for your service. Goodbye. And let's go. Our let's keyword. Okay, so let's actually make a for block right now, I guess. Or expression in wrap. Okay, so let r4 is equal to text keyword, right? 4. I guess probably padded, yeah. And then we're gonna then parse some identifier. Then text identifier. Oopsies. There you go. And honestly, yeah, first of all, I want to ignore the for loop, by the way. Ignore, then get the identifier. Right. And maybe we have to actually do padded here, but we'll see about that. Okay, so what's up now? What's up? Type annotations. Yeah, that would probably go away later on. Anyways, so after that we parse an identifier, then we have to parse another keyword, then ignore. We're gonna parse text, oopsies, text keyword of, well, in, right? Huh. Alright. Then ignore in, and then we're gonna parse an expression. Probably gotta clone this, maybe? Okay, let's do that. Do we actually need the expression like this anymore? Hold on a second. Please comment this for a second. Do we actually need the expression like that anymore? I don't think so. Yeah, let me see where we're using this. So expression. Okay, so we're initializing it here. And we are actually using it here. And I don't think we need that, yeah. That was just the remaining of one failed fix, I guess. Okay, so maybe we can just say right now let expression is equal to that, hopefully. Man, where is that thing? There you go. And we're not gonna need this anymore, I think. And we're not gonna need this either. I think we're good. Yeah, we're good, I guess. Okay, cool. So that's great. Expression clone. And so after that, we're actually gonna parse Isn't a block an expression too? But we do want to parse a block. Exactly, not just an expression, yeah. So let's parse a block now. Do we have access to block here? I wonder. I guess? Mismatched types. Expected reference or found struct. What? Where's the block? Yeah, it is that recursive thing. Alright. We're also using it there though. So maybe let's clone it. Oh, my bad. I'm saying parse. That makes sense now. Then block. Borrow of moved value. Yeah, where that got moved now? I think here. Or isn't it? I think so. Okay, cool. Though we probably want this to be padded too. Maybe. Unless if the expression is already padded. But anyways. Then block.clone. Alright, great. Block clone dot padded. I mean, I guess we'll just pad everything anyways. And yeah, I think this should work now already. Okay, cargo R. Oh no. An expected token. Why? Good question. Text keyword 4. Ignore then. Text identifier dot padded. Yeah, I mean that should work. Oh my bad. I haven't included the 4 yet into the actual parser. Okay, cool. So how are we gonna do this? Well, I think we could probably just, I don't know why we have a clone there to be honest, but I think we can just say or 4. Oopsie, not that. There you go. Maybe I need to use a choice honestly here. Oh, my bad. I see. So we need to add a new variant of this. Don't need this anymore. Okay, so let's add a 4 block. Let's go. Okay, let's add a 4 block, and what's we gonna put here? Yeah, we're gonna put the identifier for our 4 block. So it's gonna be basically src string. And then we're gonna have an expression for what we're gonna iterate into. And that's gonna be a box expression. And then we're gonna need a block, which is also an expression. I should probably make these into structs to make them more readable. For now, this should be fine, I guess. And let's just make this into a tuple so we don't have to impact that. Okay. So now let's see what we got here. So map to expression. What is that called again? For here. Type mismatching function arguments. Expected function signature. Found function signature. Ah, I see. Well, we're gonna need that anyways because of the boxing. Yeah. Makes sense. So we don't need that tuple because we're gonna need to unpack it anyways. Okay, cool. So let's do this. And so the first thing would be the name of the variable, and also the what we're iterating into. I guess iterator maybe. And so basically the iterator expression, and then finally the block. And then we're gonna make an expression 4 with the name on it, and then a box new iterator expression and box new block. To take a single tuple as argument. What? Maybe like this? Oh. Hold on. Are you using an crate? Yeah, I am using Chomsky library. Chomsky crate. Parser library for humans with powerful error recovery. And I'm also using its sister project, Ariadne, I think. It's basically from the same author, pretty much. So yeah. Yeah, Chomsky is very cool. It was very hard for me to grasp at the beginning, honestly. Man, it's pretty cool. Mismatch types. Expected tuple. I think we're probably gonna need maybe a tuple here. Ah, yeah, there you go. Cool. So now this is a name, this is the iterator, and this is finally the block. Great. So now hopefully we can actually say the or, oopsies, the or R4. I don't know why we have a clone here. Let's try this out. Oh crap. So what the heck have happened? Okay, or R4 or let. Or let or expression or for loop. Well, that sucks. But I think, oh, hold on a second. If I don't include this parser, what error it gives me exactly? I think it gives me, no, it's actually the same error. Yeah, it is. What? That's interesting. What if I pad this? I think we're returning a block here. Yeah, we are returning a block here. So either let or expression or for. So what's up with this? In my mind, this should work perfectly. Huh. Ignore then text. Oh, what the heck? Oh, yeah, it's fine actually. Ignore. Then we get a text identifier. Then we again ignore. Then ignore text keyword in the padded. Then expression clone. Huh. I have no clue how to even debug this. Name iterator block. Am I saving this? I am. Okay. Oh, it actually parsed it as an identifier, I guess. What the heck? Identifier 4. Bro, how? Okay, I see. I see. I see. Because expression also includes an identifier. Alright, gotcha. Well, that could have easily saved hours of my time, but glad that didn't happen. Okay, so we got a for loop, variable I, and we're iterating through a range from some number 0 to some number 10 with an empty block. Otherwise, you can actually hopefully say print I guess. And there you go. So the block contains a call to print identifier I. You can also, I guess, go wild maybe. Oh, we don't have assignment yet though. Yeah, we don't. We only have a let right now. Yep. But I mean, you can actually do this, I guess. So that's something. But yeah, we do need to support assignment. And the question is how we're going to do that. How are we going to do this? Let's see. So what is inside the block right now? Where is the block? The block. Okay, I need a train to go through this. Yeah, here you go. So we got a let or for or an expression. So I think, yeah, I think equals is basically an operator, right? Like, but it have the lowest precedence. So a binary operator. Okay, interesting. Okay, let's go to here. I think this should be pretty simple to actually do. Let's see. So you got the dot operator, the union operator, then the product, then finally the sum. And oh yeah, we actually also need conditions and such, but yeah. So let's see what we got here. What we got. Well, let's just copy this. And so we're going to go with the previous one, which is sum in this case. And we're gonna call this assignment, I guess, assign, equal to sum, which is the previous one, and sum again here. Oh, okay, equals to here, and repeated AB. Instead of expression dot, we're gonna have assign, and this would have lower precedence because, like, you know, it's at the end of this parser. So no variant or associated item named assign found for enum expression. The current scope variant or associated item not found in expression. No variant. Oh yeah, my bad. We have to create this. Can you actually do it? What did it do? I have no clue. Anyways, it sucks that, oh, there you go, cool. Great, let's go. That's what I'm talking about. It generated it for me. And now we're just gonna return a sign, I guess. And this should technically work, maybe. Or is it? Oh crap. What the heck is this? Okay. Box expression src. Cargo R. Come on. And assign identifier I equal to number 10. That's what I'm talking about. Let's go. We got it. Let's go. Great. Let x equal to that. That's very cool, man. That is very cool. We got 4 loops already. Pretty amazing. Do we even need conditions? We also need some other operators though. We need comparison operators and all that crap. Okay. Should we actually make a separate one for each one? Interesting. What do you think, guys, should we do next? So right now we can actually parse this whole thing. That is crazy. Cannot believe I did this. If I had to redo this, I probably wouldn't know how to be honest with you. Oh crap. Very cool stuff. Let's go. Let's go. Alright, very cool. I mean, we could go with that, I guess. Like, yeah, fine. Let's add some comparison operators right now to add conditions. So equal it's a binary operator, right? And we also gotta have not equal. I don't honestly. Not equal. Well, let's just go with that for now. And we're also gonna have, let's say, an if condition, if statement. So for the if statement, we're just gonna have a box expression, which is gonna be the condition. And finally the block. Cool. Cool. Alright, equal if. So let's actually do this. So first of all, what kind of what is it called? Precedence we want to give this. So it should have more precedence than assignment, I think. Yeah, for sure. Though I don't think it's gonna have more precedence than some. So we're gonna put it here, I think. Let, what is it called? Equal, right? Is equal to, well, we can actually use this one, I guess. But no, anyways, let's just use this for now. Okay, and this would be, I guess, like this. Okay. Ignore then sum.clone. Yeah, that's true. And now instead of sum here, we're just gonna say equal. And here instead of a sign, we're gonna go with equal. And there you go. Done. We have added it pretty much. So let's just cut this real quick. Let's say x is equal to, well, I mean, let's just say x is equal to that. And let's see if this works. It should work. Why it's taking too long, man? What? That's unusual. Huh. Did I blow the Rust compiler somehow? I mean, look at those types. That is wild. Oh crap. Well, I guess let's keep it cook. There you go. Okay, cool. I don't know why it took that long to compile, honestly. I guess we have reached its limit. We have to box those parsers, honestly, to make it less heavy on the compiler. Okay, so we have a block with an assign x equals to number 10 and 20, which is amazing. Perfect. Perfecto. Let's go. Okay, cool. Let's actually take that back. Now, it should be easy to implement the if condition too, I think. So, for the if condition, how we want it to be like, basically if, and then here you're gonna have some expression, right? And the block, as simple as that. It's very, very straightforward. So, do I want to reuse this? I guess so. Let's say if condition here, keyword if. Oopsies, what I've done there. Should be a piece of cake right now to parse XML, HTML, JSON, whatever, using Chomsky. That would be cool videos in the future, I guess. If condition, I mean, right now we have parsed the whole language. Similar to Rust to some degree. There you go. Alright, so we got if condition, great. Padded, ignore then text ident. No, we don't need this. So we're not gonna need, we're not gonna need this either, I think. Dot then expression clone dot padded dot then a block padded and then map it to if condition, and we don't actually need that. Just gonna have, oopsies, it's gonna have the condition and the block, I think. Oh, what? Oh, I see, makes sense. So let's ignore that keyword and condition and block. Cool. So now the expression if, we don't need the name here. First it's gonna be box new condition, box new block. I think that's basically it. It's that simple. Hopefully. Yeah, it should be that simple. Oh crap, hold on. I need to add it here. The or if. And let's go. Let's see. gonna take that a while again, I guess. And I should probably do something cool here before it compiles, because it loads the file at runtime though. Parse error, huh? Oh, I see. And if equal number 10, number 20, block, false. Okay, we have done it. We have added conditions too. There you go. Like what we need yet right now. Oh, I think we also need an array. So like you want to be able to, I guess, make a list is equal to something like this, or whichever, or something like this, or I don't know. Basically a list of expressions, you know. So how are you gonna do that? Okay, it should be very simple actually. It's just gonna be a tuple, but like, why do we need the list then? It's supposed to be dynamic basically, so I guess. Expression clone separated by just that, allow trailing, collect. Okay, so let's copy this tuple. Let's make it an array, I guess, or a list, or whatever you want to call it, I guess. And then we're gonna have expression separated by just those, allow trailing, sure, collect vec, delimited by just these. I don't think parsing can be any easier than this, to be honest with you. Array? Okay, so you know what's the next level of this? Is to make some sort of like domain specific language for making parsers using Chomsky, using Rust. That's gonna be insane. Yeah. Okay, array. Well, like this is just basically my little learning project to get familiar with how to parse stuff using Chomsky. And so far it's been a success. I really loved it. It was so much fun. So now let's actually add this array, I think, into the mix. But before we can do that, we have to make a node for this. So array, and then we're basically gonna have a vector of expressions. src. Of course, we don't need a block because vector already allocates its stuff in the heap, so that's not a problem. All right, so vec expression src. Now what we could too simply do is where is it? Array, yeah, delimited by just that. Now we're just gonna map it, yeah, map the thing, I guess. And I think this is basically the elements, right? Yep, there you go. Well, I mean, we could just say this. We could just say expression, I think. List or array, yeah, array. Come on, bro. Let me stop this. And let's see. It's surely the compilation is slowing down. So I do need to box these parsers to make it a bit faster. But anyways, cargo R, come on. There you go. An expected token. Oh, but why it's saying it here? Weird. Either way, I don't think we have added this yet. Did we? Yeah, we didn't. Oh crap, I hate this. Cancel. An eternity later. Building, building. Crap. And did we make it? There you go. That works. Okay, so we got if conditions, for loops, we got lists, we got iterators, I guess, we got closures. So yeah, all the parsing stuff is there, pretty much. Now we gotta add enums, we gotta add structs. The list never ends. And honestly, I think you got the point. You can pretty much, I think, parse anything you can think of, as long as it's consistent and non-ambiguous grammar. Well, that was very fun. I think I'm gonna stop the stream for now. So I'm not sure honestly if I want to do the the evaluation of this language. That's gonna take years too, I guess. But yeah, overall I think I've got a little bit familiar with Chomsky, and that's very amazing. Finally I can get to write some parsers, because I just need those a lot. Like a lot of times I think about, like, I need a parser for something, and then I just realize that I don't know how to write parsers. But there you go. Cool. Let's go. So yeah, that was it for this stream. Thank you guys for coming in. Thank you, Theo Paris, Robert, Enoch. And yeah, thank you for tuning in, and see you later, everybody. Thanks. Bye.